Hey, this is Unit 2, Topic 2, Lesson 4, and it starts off with a warm-up about finding geometric sequences. So it starts off with a question which has a common ratio, because we're talking about sequences, means multiply, of times 4. Times 4, times 4, times 4. So it says find the constant ratio, so the ratio is 4 for each geometric sequence. This one goes from a half to 1 to 2 to 4 to 8. That means the numbers are being doubled. So the ratio here is 2. If I was going to write the equation, that would be starting point times rate to the power of x. Now, it depends. Do you think of 1 as the first term or the 0th term? I kind of think of it as the first number in the sequence, so I'd have to write minus 1 here. If I was going to write this as an equation, I know I'm not asked to do so, but I'm going to do so anyway. It starts off with 1/2, but you know what? I'm gonna do something a little different. I'm gonna use the second term. I'm gonna use 1 times a rate of 2 to the power of x minus 2, and I avoided having to use the 1/2 because I used the second term. But since I used the second term, I have to do x minus 2 here. All right, so here we notice that the numbers are going from positive to negative to positive to negative, and vice versa. Negative to positive. So that means it's going to be multiplied by a negative number. In this case, it's going to be negative 2. The ratio is negative 2. And if I was to do that, it'd be starting point times the rate to the power of x minus 1. And I'm calling negative 5 the first term, which is why it's x minus 1. All right, so now that we notice that the numbers are getting smaller, that means we're being multiplied by a fraction. So the ratio in this case is 1/2. So 10 was the first number times 1/2 to the power of x minus 1. All right, so like I said before, this lesson is about finding patterns and writing equations. So basically, it's everything we've been doing for the last couple of lessons and putting it all together. So there was an example given here. So the first thing you need to do is identify what type of sequence it is. So I'm going to find the pattern. So from 5 to 10, and 10 to 20, and 20 to 40, there's a common ratio here of times 2, which is the reason why I've circled geometric. So how do you find the next term? Well, you start with 5, and you're going to multiply it by 2. So the previous term. So that's what it says here. And the reason why you're writing to find the next term, because that's what helps you write the recursive rule. Because that's what all a recursive rule is basically it's telling you how to find the next term. So the recursive rule in this case, so I would say f of 1 is 5, and then that means to find any number, f of n, you would do that by taking the previous number, f of n minus 1, and multiplying it by 2, times 2. Done. To find the nth term, so how would you find any term? To find the nth term, so in this case it says start with 5 and then add 3n amount of times. Well, in this case, you're going to start with 5 and multiply it by 2n amount of times. So if I do that, so I'm not writing it because I'm trying to save time here. So that's basically writing the explicit rule. So notice that number 2 helps you do number 3 and number 4 helps you do number 5. So starting with 5, I'm going to multiply it by a rule of 2 x amount of times. But remember, that's the first term, so I have to put minus 1 right here. All right, so the next question is going to be the trickiest one, and I kind of already started it because this one is neither. You don't have to worry about this one right now. Matter of fact, this isn't even quadratics. We don't even do this question at all in Algebra 1. But some of you are going to ask me, hey, Mr. Phelps, so I want you to show me some Algebra 2 and higher level math. So here it is. I basically did do it, so it's plus 2, plus 4, plus 8, plus 16. So you can see the pattern, and you notice that the amount that's being added is being multiplied by 2. Yeah, those are times 2s. All right, so I wrote out the explicit rule, and this one actually took me a minute or so because I had to figure this one out as well. It's kind of interesting how it works out. If you're trying to find the next term, what you do is you double the previous term and subtract 1. So look at this. If you double 3, you get 6. You subtract 1, you get 5. It works. Double 5, you get 10. Minus 1, you get 9. It's always 1 less than double the previous term. So there's the explicit rule. So that one makes sense. The recursive rule is pretty crazy. So starting point here, so to find any number, you take the previous number and you add double the difference of the 2 previous terms. Yeah, okay. So you take the previous term, which is 9, minus the 2 previous to it, which is 5. That'd be 4. Double it, and you get 8. So you have to add 8 to the previous term. Wow, that's kind of crazy. Okay, well, I showed you, so I stuck with my end of the bargain. So -8 to -17, that means that's a decrease. That's a arithmetic sequence. It's adding -9 each time. Okay, so the recursive rule, so that would be f of 1, or I'm going to use subset notation in this case. I like subset notation better than myself anyway. So f sub 1 is equal to -8. I think it's easier to write. So then f sub n is equal to f sub n minus 1, and then you're subtracting 9 each time. So that's the pattern. For the explicit rule, this is a linear equation, so it's going to be y equals mx plus b format. So you would have f sub n, if I stick with function notation. No, I'm going to go with, function notation. F sub n is equal to, I said sub again. F of n is equal to, so you have a pattern of -9, so it's -9 times n, and then plus the 0th term. So if I work this way backwards, I would have to add 9, so that would be plus 1. That should always work. Number 5 is a geometric sequence. It's times -3 times -3 times -3 times -3. All right, so the recursive rule, I'm trying to save time here. I'm going to go straight to explicit. Recursive rule is basically going to be f of n is equal to f of n minus 1 times -3. The explicit rule. So we've done a couple of practices of these. So we can say y equals, I'm just going to write in regular notation, y equals starting point, which in this case was 2, times the rule, which is -3, and 2 was the first term, so it's x minus 1 power. The last one, I know there's fractions involved, but really isn't that difficult. It's an arithmetic sequence. Add 3/5, add 3/5, add 3/5. It's pretty obvious in the first one. It goes from 1 to 1 3/5. Well, it's increased by 3/5. That one's pretty obvious. But the next one's actually not as obvious. So 3/5 plus 3/5 would be 6/5, but that turns into 1 1/6, and you have to add that to the whole number. So yeah, that one's not as obvious, but that is add 3/5. And the last one is pretty obvious. 3/5 plus 1/5 makes 4/5. You can clearly see it's plus 3/5. So the recursive rule is going to be f of n is equal to f of n minus 1 plus 3/5. So you're adding 3/5 to the previous term. The recursive rule, it's a linear, it's an arithmetic sequence. So that means it's going to be y equals 3/5 x plus the 0th term, which was given to us, which is 1. That wasn't so bad because that was pretty nice because they gave us the 0th term. All right, so getting to the homework. So you're doing a lot of the same thing for the homework. They're giving you a table, and you're finding the recursive and the explicit rules. So first thing I want to do is find the pattern. This is plus 2, it looks like. Plus 2, plus 2, plus 2. That's 11. That's 13. So explicit rule, that would be y equals 2x plus the 0th term. If I take that backwards, would be 3. 2x plus 3. There's other ways of writing it. You can actually use any term like you can for exponential functions as well, but I'm going to stick with that. So recursive rule, that would be f sub 1 is equal to 5. And then f of any number is found by taking f sub n minus 1, the previous number, and adding 2 to it. All right, number 6. First, I see the pattern. It looks like it's adding -2. So this would be -8, and this would be -10. So the explicit rule will be y equals -2x plus the starting point. The 0th term would have to be 0. So it's just -2 times x. -2 times this is this. -2 times this is this. Recursively, hopefully you're finding recursives easy by now. The first term is -2, and f of any number is found by taking f of the previous number, and all you have to do is subtract 2 from it. Done. And last question, number 7. So we've got, it looks like a geometric sequence. It's multiplying by 3. 9 times 20 times 3 is 27, times 3 is 81, times 3 again is 243. So the recursive, now let's go explicit rule first. So that's going to be y equals, starting point was 3 times a pattern of 3 to the x minus 1 power. Now, like I showed you before, you can actually write an equation using any point. You could have said 27 times 3 to the x minus 3 power. So if you put a 27 on the outside, you've got to use x minus 3 as your exponent. The recursive last part, f sub 1 is equal to 3. That's a starting point. And then f sub n is equal to the previous term. And all you've got to do is multiply it by 3. All right, so that's it. Hope this helps. Let me know. Thanks.